Hi developers, in this video we'll learn how to use CustomVision to create and train the model. With cognitive services we can analyze images to detect objects, but we cannot detect anything. For this specific case, CustomVision could help, because we can train it to detect specific objects that we already know, so that after when the user want to analyze an image, it can tell him that this tag is present or not in that image. I'm Hossein Delai, Microsoft MVP. Join me here to show you a demo on how to do this. Let's start creating a new project for Paris monuments that can distinguish between Eiffel Tower or Arc de Triomphe. Then we'll choose the domain, and you see here we have some domains with compact. That means it could be exported to Android or iOS. We'll choose landmarks because that's the one corresponds to the type of our project. Once the project is created, we need to upload images in order to create and train the model. Here I'll provide some images that I have downloaded earlier for Eiffel Tour, and I'll tag those images as Eiffel Tour. I write it in French, Tour Eiffel. I'll upload those 9 images, and here make sure more images means more accurate model. Here I am just uploading 9 images. Once those are uploading, now I go and upload other images for Arc de Triomphe. So I go and tag them as Arc de Triomphe. Make sure the spelling is right. Then I'll upload those images. Once that's done successfully, now I'm ready to go and train the model by just clicking the button train, and that will so the services on Azure will train and create the model for us. And here we get some indexes for the precision and for the recall. The model is created. Now we can go and test it. For that, I'll go here and provide either a public image URL or a local image. I'll provide a local image that was not uploaded previously, so this is a new image, and now the model should be able to get the result. And here it tells that the tag is Arc de Triomphe with a precision of 87.3%. Let's try with another image for Tour Eiffel, for example, and here it knows that it's Tour Eiffel and it's sure by 99.9%. Great. Now we said that those images could be used as online endpoint. So here we do have all the information for how to invoke this model. So we have the URL, and we also have the prediction key, which would be used in order to access that API by only you, so no one else can access it. Also, this model could be exported to your mobile applications, either iOS or Android. For iOS it uses Caramel, for Android it uses TensorFlow. So if I click on iOS, then I do here have the button for export that will download the model for me. And if we take a look at this model, it's only 2.8 megabytes, so it's a small file that you could include it inside your iOS application or Android in order to do the predictions in offline mode. If you want to get more information about how to use this downloaded file, then you might go here to a sample code, where here inside this GitHub repo you will have a sample iOS application that shows how to include that model and how to invoke it from our iOS application.